So the talk that I'm going to give is very similar to one my esteemed colleague John Fulton here in the chat room also gave. He has a very similar job that I have in Columbus, Ohio. So thanks for coming out, John, to see me butcher your presentation. But today what I'm going to talk about is how novices learn how to code. And that comes from my experience as a boot camp instructor. I teach at a coding boot camp called Tech Elevator that has locations throughout the Rust Belt. It started in Cleveland, Ohio in 2015. They opened up in Columbus and Cincinnati because apparently it's easier to do in the state of Ohio than Pennsylvania, but they eventually came to Pittsburgh. And we also have offices in Detroit and Philadelphia and a live national remote class now that we're all in lockdown. Oh, thanks. Good link. Okay, and so I've been teaching as a coding bootcamp instructor for 2 years. I was the first person in Pittsburgh, but we'll get to me in a second. The first slide is something that is a good idea here is why do you care? Why are you here? Why does it matter, right? Whenever I'm in a conference session, I'm thinking to myself, what do I want to get out of this? And if you might not be a boot camp instructor or a academic or anything like that in the future, but you may be helping out future developers. If you have a friend who's interested in becoming a developer, usually when I have friends who find out that I'm a developer, they have some sort of app idea for me where they come up with the idea, I do all the work, and then we split it 50-50, right? If you are onboarding a junior developer, or maybe you're assigned to be a mentor for somebody who's new to it, some of these things might apply to you when you are trying to keep in mind back in the day before you learned how to program, what was your mindset? What sort of assumptions were you making that you weren't aware of? Let's see here. There we go. Thank you for that. There is the slide. Why do we care, right? The intro slide is how novices learn to code, what I've learned by teaching in a boot camp. And then the next slide is why do you care, right? And also, if you have friends who you think should become developers, or you want to give advice to them, this kind of stuff can help you. Okay, so let's see here. Here's my quick profile, and I think that the real thing I want to drive home here is I am a practitioner, right? I am not an academic, right? I've been in the field for 20 plus years, which, wow, when you put it that way, okay. I've gotten my undergrad in electrical and computer engineering from Pittsburgh's own Carnegie Mellon University. Go Tartans! They were dumb enough to take me back, so I went back to grad school and got my MBA. And I have a very diverse background. I have some friends who have spent 15, 20 years with the same company, but I'm the complete opposite of that. I've worked in big companies, small companies, companies where tech was the main product, companies where it's retail, and I'm helping out in other capacities. I've worked in consulting firms, startups, you name it. And that variety of experience has helped me when I'm teaching students, because they generally go off into a new career and want to see what their options are. And I can speak with some amount of authority and experience because I've had a lot of those experiences. I started out in hardware. I eventually moved over to embedded systems. I worked at Motorola on cell phones. I worked at Intel on the Pentium 4. I've done a lot of stuff on hardware, but I eventually got drawn into software like most of you. But the important thing is I bounced around and I eventually found the job that was right for me and the job that I love. And I've been at Tech Elevator in Pittsburgh since its inception in 2 years ago, 2 summers ago. I've been through 7 different cohorts now. I was the original instructor. I helped get the campus launched. I was there drilling holes in tables and using Allen wrenches on IKEA furniture. So I've been there since the beginning of the Pittsburgh launch. So what I really want to underscore here is that I am not an academic, right? I don't have a master's in education. My sister does, for example. My sister is what I call a real teacher. She has her master's. She has a lot of certifications in special education, and she is a teacher to this day. So sometimes I get to rely on her for her insight, but the fact that I went from being a practitioner to somebody who's trying to teach students has been a challenge for me. Okay, so here is the spiel on Tech Elevator, right? The company that I work for. I wanted to give you a little bit of background and what all of my perspective comes from here. We're a 14-week coding boot camp that does full stack development. You can come in if you have the aptitude, and what we do is we train you and coach you up to get an entry-level position somewhere here in the Pittsburgh area, and get you an entry-level job and just get your career started in tech. And we're very, very transparent. Our numbers are really good. And this was important to me before I ever accepted the job, right? I didn't want to get involved in like a for-profit education kind of a scam, right? Some of those make the news for unfortunate reasons. But I've seen it with my own eyes. Tech Elevator, it does work. It is amazing. And I really love this job, and that those numbers are for real. And we are very transparent. You can check out CIRR.org, CIRR, the Council on Integrity, Results, and Reporting. We open up our books. So it does work, and it speaks to Pittsburgh's booming tech industry as well. Okay, so what have I learned during my 2 years, 7 different cohorts, right? We break these down into 14-week sessions we call cohorts, and I've been through it 7 times now. Graduation is tomorrow for the current cohort. So again, I cannot stress enough that this is not research driven. There are no papers up for peer review or any scientific method. This is more anecdotal, right? This is empirical evidence of what I've seen through maybe 200 students coming through the program now. Some of them have backgrounds in coding. Some of them have never, used the computer for more than opening up Chrome. But there is a lot of research out there that is really fascinating, and it's not just about how children learn and the development of their brains and how the things get absorbed. Stuff like my sister would have learned about when she was training. But this is more about how adults learn. The average age of our student is 31. So by the time we're 31, we're a little more set in our ways, and so teaching them takes some slightly different techniques. But there's plenty of stuff to read about, lots of good stuff on how to get through to people. And one of the points that my esteemed colleague John made that I thought was really salient was that all of the points of what you can teach are very important, but they don't all apply to all of the students, right? There are plenty of things that you need to learn and keep in mind, but they only apply to certain types. Okay. This might be a tricky thing to deal with, but not everyone is cut out for this, right? I don't mean that not everybody can learn to program. I believe we as a company believe that everybody can learn to program. Maybe not everybody can do it in a 14-week compressed, difficult, butt-kicking schedule, but everybody can learn it. It's not inaccessible to anybody. However, the good point here is that not everyone should do it for a living. As we all know, coding can be difficult. It can be tedious. It can make you bang your head against the wall and make you wonder why you even got into the field. But if you love it, if you find the joy in programming, if you love the high of thinking, yes, I figured it out, this is great, you have to want to be able to do it. So when we look at students, we ask them for, we look for their abilities in terms of problem solving, basic algebra skills, ways that they are able to express themselves, but also motivation, right? Are they in it because they enjoy solving problems? Are they in it because they want to, they're going to enjoy programming? Or are they just in it because they play a lot of video games and they think that they'd be good at it? Or are they here because they hear tech people make more money, so they just want to do it for the paycheck? So we assess all of those kinds of things, and it's important to know that maybe you get through the program, maybe we get you an entry-level job, but for you to stay in this field, you have to genuinely enjoy it, so that will help you get through the rough patches. My sister does special education with children. That sounds like a bad job for me because I may be patient, but I'm not that patient. I'm not great with children the way she is, and I'm very jealous of her skills. But you know, we're all cut out for different kinds of jobs based on our motivations and personalities. So it's important for you to know that if you are talking with somebody who's interested in getting into the field, for them to stay in the field, for it to be a good match, that has to be for the right reasons. And then another thing that we like to talk about at Tech Elevator is that programmers learn by programming, right? You have to do these things. You have to actually have the skills. You have to have the code coming out of your fingers for it to really set in and to make you into a programmer. Learn by doing, right? So reading things, watching YouTube videos, doing, you know, these kinds of lectures, coming to talks, tutorials that say hello world, those are all wonderful. But in order for you to retain things, in order for you to become, you know, fluent in a language or a technology, you need to actually do it. You need the repetitions. So we teach our students by giving them exercises every single day. Our usual daily cadence is there's a lecture for 3 hours in the morning, 9 to 12. That's a lot of talking. And then a lunch break. But then there's also some exercises corresponding to the lessons of the day, so that we have this sort of learn, apply, learn, apply, learn, apply cycle every single day. And yeah, figuring out what you're doing wrong and having that instant feedback is I don't want to say a shortcut to mastery, because that's not really possible, but it's essential to be able to learn to get that feedback right away so that you can continue to improve. And then another thing to keep in mind is that some things are harder to learn than others, right? There are some things that students grasp generally quickly about programming, but then there are some things that are a little bit trickier, right? Cliff events, right? Like you're walking around and then you just fall off a cliff. Those tend to be collections like lists and arrays and things like that, because, you know, it's one thing to say here's a variable, but then to say here's a collection of objects starts to get into a little more abstract thinking. And students who haven't done this before are using new parts of their brain that they might not have exercised quite as well in the past. Other events that we've seen, calls to functions with parameters, right? Sometimes it blows their mind if you say, okay, here is a method, we're passing a value here, and then here is a copy of that value somewhere else that might have a different name. How do those two things line up, right? Just to always be thinking about what your mindset was when you first learned to program is a crucial step to becoming a very effective instructor. Think back to when you were learning, what your assumptions might have been and why you might not understand certain kinds of things right away. Encapsulation, right? All of the fundamental principles of object-oriented programming, those are a lot more abstract. Students who are still getting used to saying, you know, if this, for that, why all of this, they might not be quite ready for the more abstract concepts. And by the way, I should mention that Tech Elevator is an object-oriented programming-oriented boot camp. So for anybody out there who is procedural or functional or anything, sorry, all of my stuff's going to be OOP related here. Another cliff event is frameworks, right? Inversion of control sometimes can really throw some students off. Like, wait, why is this running? Why is that calling my code? Where did that object come from? That just showed up, right? So you have to sort of anticipate when a student is going to need some more time to let things soak in and come back to it later. Another good example is exception handling. That is something that students have a hard time with, the flow of a program. And we usually spread that out over 2 days, not because there's 2 days worth of material, just because we know it's going to hit them and we want them to have a night to sleep on it before coming back to it again the very next day and saying, yes, this try-catch block can really can change the way the program operates, and we're just going to have to get used to that for a little bit. All right, what else is there? Oh yeah, so back to repetition, right? This is very important in terms of learning to be a programmer by doing things, right? Practicing it every single day. One thing that John has said is that teaching or telling somebody something is not the same as teaching somebody something. And as a lead developer, maybe you're the team lead or somebody who is training a newbie or somebody who just got to your team. You might be frustrated when you say, I told you that yesterday. Why didn't you remember, this rule or the procedure that we're using? And just because you told them that doesn't necessarily mean that they're going to remember and hang on every single word that you say. Usually about 3 repetitions will get somebody to, have it stick. And so it's important when you're constructing your narratives in class to have a way to come back to something at least 3 times before you can safely assume that they're going to remember that. It's not as easy as just saying, I don't know, Booleans are true or false. Booleans are true or false. Booleans are true or false. If you say it 3 times, it's not like Beetlejuice. They're not just going to magically remember it. You have to be able to come back to it a couple of different times with spaced learning and those kinds of theories. Okay, and so during the COVID era here, like we are now, like why this is remote instead of in person, things are distracting in the classroom for sure, right? Phones will buzz and, people will lose their attention span. They'll go check Facebook or Twitter or whatever the cool kids are doing, TikTok, I guess. Being remote's even worse because now you're surrounded by every distraction that you own in your house. All of your Netflix or whatever else is now available to you. So staying focused is difficult. Generally, you have about 10 minutes of a student's attention before they have to tune out and come back in later. So it's important to keep that in mind. You want to keep repeating so that you'll catch them during some of these moments when they're tuned in. We also do a lot of exercises, not just one, but also the wax on, wax off concept from the Karate Kid, right? Where Daniel-san doesn't really even know that he's learning karate, just practicing these moves over and over again so that they come second nature. There is one assignment, for example, I think it's on day 2, our exercises are, you're just declaring variables 50 times, right? There's 50 different problems to do. And I remember algebra class when I would have to do, 1 through 99 odd, because all the odd ones were in the back of the book. And I just have to do it over and over and over again. After 10, 11 of them, I'm like, geez, I get it, right? This is how you solve a system of equations or whatever. But we still have to do every single one to get credit for our homework. And that really burns it into your mind. To this day, I could probably derive the quadratic formula. But yeah, you do it over and over and over again. And then, declaring variables 50 times means that, one of them is create a variable to hold the number of buttons on your mouse. So students will have to type in int number of buttons on mouse in camel case equals 3 or 2 or whatever. And just to get them to the point where it just comes out of their fingertips without them even thinking about it is crucial to building their confidence, building their skill level, and making sure they feel like they're progressing, that they're getting that positive feedback loop immediately, which will encourage them to continue down their journey and not get frustrated, because it can get frustrating learning programming, as you all know. Okay, so when it comes to the in-class instruction, the beginning part of the day that I was talking about in our daily cadence, where I'm up there rambling for 3 hours a day, one thing that we've noticed is that just reviewing code, it's pretty boring, right? If you just say, here's a block of code that does something, let me explain it to you line by line. First, I'm going to declare a Boolean variable so that I know when to break out of this loop or whatever. That's boring, right? I was even kind of bored just completing that sentence. And students who are reading it just feel like you're translating a foreign language literature for them. They don't necessarily follow along on that. So it's tempting, right? It's sort of like an easy way to get through the day or to get through the lesson, but that doesn't really help them learn anything or retain the points of the learning objectives of the day. It's better to live code in front of them, right? That makes it more interactive. We have a screen set up in the classroom where my screen is shared amongst all of the tables. I guess it doesn't matter right now because it's real easy to share a screen, except for me at the very beginning of this talk because I had a hard time sharing my screen. But if you can share your screen and let the students see you coding and make it more interactive, it's, challenge them, say, what do I do here? Or why do you think I do that? Or even better is to do something that's wrong and see if somebody stops you, right? Just that level of interactivity, that level of engagement will keep them paying attention and keep them learning. And even better still is to have them code along with you. We use Git in some really interesting ways so that we can send out a blank copy of a file and then let them fill it out and then push their version of it back and not collide with anybody else's, so that we can get all the submissions from each individual student. But what this allows us to do is say, here is a template, right? Maybe we don't want you to have to build a whole project by yourself with a build file and all kinds of extra stuff. It's just, here's the empty class. Fill out this main method here. And if they're coding with you, they are engaged. They are learning things. They're trying to, if they don't know exactly what they're typing at the time, they'll know that there will come a time when they need to understand it. So they're sort of following along and getting better at it, even if they don't know exactly what they're typing at all times. Speaking of, in showing them what you're doing as you're doing it, one of the most awesome words here in the German language, I assume, is Schadenfreude. The idea that somebody is enjoying your misery, right? And it's not because we're all intrinsically sadistic. It's because it's important to fail in front of your students, right? They love to see that you are not perfect. You want to sort of fight against the idea that there's this sort of binary have not idea in the programming world, that because you've been doing it forever, you're great, you're perfect, you don't make mistakes, you write it the right way the first time, kind of like all the people who comment in Stack Overflow are just always perfect. You don't want to show that to your student, because that creates this mental barrier where they feel like they'll never get there, right? So being able to say, oh my gosh, I screwed this up. And usually there'll be some show-off student who's like, oh wait, I see where you went wrong. But it's good to let them see you fail, to know that even the people who've been doing this for a long time can still screw it up, and that's okay, right? You just don't commit it yet, right? fix your compiler errors before you push it up. So yeah, they'll remember when things go wrong. If you get everything right, start to finish, they'll feel like they are very far behind, to the point where they won't even try anymore. So it's good to it's one thing to say, everybody screws up, don't worry about it. But it's another for you to, do it live in class. You're demonstrating so much code, you might as well demonstrate some failure, because that will be part of their lives. And then, along those lines, programmers do get stuck, even the good ones, right? Even the experienced ones, I should say. Any given line of code can have, plenty of things going wrong, right? Syntax errors, or this object's actually null, and I expected it. I assumed that it wouldn't be, so on and so forth, right? You guys know all of the errors that could happen at any time, and so it's not always easy to see what's wrong just right away, and especially not for a student who's learning this from scratch, right? So some of these students were delivering pizzas 3 months ago. They have no idea what's going on, so they don't have the finely crafted error spotting eagle eyes that you might have. So, it's good that you're there to help them out, but it's even better if some of their peers can help them out as well. Not so that they compare each other, but, just sort of a we're all in this together mentality can really help students realize they're not alone and they're struggling. And that, if they are doing a little bit better, teaching another student is a good way to solidify that knowledge. And as somebody who was a practitioner and now has to teach it to other people, there are plenty of things that I didn't realize I didn't completely understand, right? There are a lot of things where I said, well, this works, or I copied this, well, I copied it from Stack Overflow, but I followed this pattern, or this is what we're doing up here. So as long as I do the same thing down here with this other object, it's going to follow the same pattern. So my boss can't be mad at me about that, right? But in order to teach something, you have to go back and say, well, wait, why is it that is true? Or does that really work? Or, oh, I guess that makes sense. So being able to teach somebody else will help fill in your knowledge gaps more than you would expect. I know that from firsthand. Another thing that's important to get across to new programmers is putting code in the right place. Generally, when we see students start out, they're just excited to get their homework done. They're just excited to get the project going. And they tend to write stuff that's very procedural. It looks like a script, right? They're like, do this, now do this, now do this, now do this. Oh, it works. Great. Submit, right? But I say, okay, that's great. And I'm proud of you for getting it to work. It does work. However, the second level thinking is, where does this code go? Where does this really belong? And that helps me get into some object-oriented programming principles, right? The idea of encapsulation, the idea of loose coupling, that kind of stuff. I'm like, well, should this live here or should this live over here? And then the problem solving becomes less about just get the computer to do what you want, and more about where the design patterns start emerging. Where do things actually live? So we do teach that quite a bit, but that doesn't necessarily come right away. Usually the first projects we see are very, they have some of the God object thing where you just instantiate one object that has all the data, all the methods, or maybe every single thing is a static method because they can't quite wrap their brains around object-oriented programming. But that's okay. You want to encourage them and say, that's correct, that works. Let's think about it on the next level here. How would we make this more maintainable or scalable? Or assume that your boss is going to come in tomorrow and completely have a whole new assignment for you. How would you get that done with as little code as possible? So we try to keep things very practical. Programmers doubt themselves, and that is something that we all do, no matter where we are in our careers. So I think that's important to let them know that, right? We're not we're not infallible. We make plenty of mistakes, and it's normal for them to think that that's not true. So it's up to you to let them know that. So yeah, positive feedback is always very important. Encourage them. Like, there's always something that could be improved with code. And the idea is, don't just jump at that and be like, no, this could be better. Make sure you say, this is good, right? You did a good job. You went from 0 to 1. Now let's get from 1 to 2. We talk a lot about imposter syndrome as well, because there are plenty of times throughout an intensive 14-week boot camp where students will feel like they shouldn't be doing this. They should go back to whatever their other job was. Maybe they're not good enough, or they see somebody else who's picking up on things a little quicker, and they'll get frustrated. And they'll be, some days they'll think, oh, this is great, I got my homework done. Other days they'll think, I don't know any of these technologies on this job description. Why am I even applying for this? So we let them know that everybody feels imposter syndrome at every point in their career. Much like failing in front of them, it's important to know, we're not perfect. Okay, and then using debugging. That is something else that I think is very important for junior level programmers to enter their jobs knowing how to do. Being able to have some facilities about you to use a debugger means that you might be able to solve your own problem before bugging your boss, which is always a very risky proposition sometimes. So what we do is we generally tell our students, in the beginning, we're very loving, we're very Mr. Rogers-like, but towards the end, we start to pull away from them a little bit just to give them room to get better on their own. And in the beginning, I'm happy to help with anything. Towards the end of the cohort, though, I tell them that my first question to them is going to be, what have you tried? Right? I don't want you to just plop your laptop down on my desk and say, yeah, it doesn't work. Well, why not? Why do you think it doesn't work? Why, let's read the stack trace, all those ats in the red text. Let's see what those are actually trying to tell us, right? What have you tried to make this work? Do something to show me that you are trying to solve this problem on your own and not just dumping it on me, right? And so one of the best tools for diving deeper into what you can try first is the debugger. And for whatever reason, it's very difficult to get students to use the debugger at first. It's tricky. It's running in a different mode. It's a hard thing to wrap your brain around. But once they see the value of being able to just rip open the the runtime and see what's actually going on the inside, if they can master that, then they can answer a lot of their own questions and really show off to potential employers that they know what they're doing. So we try to come back to the debugger as much as possible. I had one student who graduated and went off to a company that had just hired 2 computer science grads. And she was sitting there, and she was paired up with one of the new engineers straight out of college, and they were having a problem. The first thing she said was, "Oh, okay, I don't know why this is doing this. Let's check out the debugger." And the student or the college grad that she was paired up with said, "Wait, what? What's the debugger?" They had no idea. So she was able to save the day from the debugging experience. But it's a very important thing to drive home. And then in a more abstract sense, the thing that we're really trying to do here isn't necessarily give them tools as a programmer to just say, here, type all this stuff up, good, you're a programmer now. It's to get them to think like a programmer, to get them to use their intuition, to get them to start thinking in common patterns that they might not have been used to before. And programming is a creative activity, right? There are plenty of ways to solve the same kind of problem. You are creating something where something didn't exist before, so there's lots of room for interpretation. But what we really want them to do is develop their ability to spot patterns, their ability to think through a problem. Yeah, like one of the things that I did in college for my signals and systems class, which was a real pain, was to just do problems over and over and over and over and over and over and over again until I could see patterns, until I could see, okay, this one looks like this one, or this one reminds me of one that I've done before. Or maybe when you're getting ready for a tricky job interview, you might be practicing different kinds of problems so that you know that whatever they ask you, you've seen some sort of thing like that before. Maybe you start to learn that, I've seen this problem before. This lends itself very well to a graph data structure, or maybe this lends itself well to depth first search algorithms, or whatever. You start to recognize patterns, and that's part of the repetition as well. So we do a lot of working on problem solving skills, and another important thing is learning to trust intuition. Right? We do some whiteboarding as well. We try to get students used to the fear that gets into you when you have to go up and do a whiteboarding problem in front of somebody, right? And it's fair to say, look, you're asking for a job as a programmer. They're going to prove that you can program right then and there. And you have to go up to the whiteboard, and you're standing up there and you're shaking and you get armpit sweats, and we want you to be used to that before you get out there into the world and you just get run over by this bus because you haven't been in the technology field before. So I've had a student go up to the whiteboard, and he was a fantastic programmer. He picked up on things quickly. His homeworks were good. He asked really good questions. I was very happy with this guy. And then I gave him a practice whiteboard problem, and he went up there and he just froze. He was so nervous, he just froze. And from working with him, I knew he knew how to do the problem. It was a pretty, straightforward one, but he just froze. He could not handle the stress. And so we try to get them to get over that barrier. We try to get them past that mental block and just writing code without thinking about it. And then a step farther is to say, all right, I'm not sure this is right, or I'm not so afraid to write anything. I'm just going to trust my intuition. I have to look at every element in this collection, so I'm going to write a for each loop or whatever, and just let them trust their ability to solve a problem, even if it's in front of somebody else, which is always very daunting. Another thing that John likes to say, and I love this, and might be controversial, and I apologize if I'm ruffling feathers here. Programming is not computer science. Computer science is not programming. Oof. Are we okay with that? Computer science is it's a rich, multifaceted discipline, right? There are elements of mathematics. There are elements of electrical engineering. There's a whole history of how things are developed to this point. It's a rich field where you can spend your life studying it and always find something fascinating about it. It's awesome. Programming, we see more as kind of a trade, right? The ability to write some code, or the ability to actually do the work, right? I've had students before come through with computer science degrees from really amazing universities, but they just felt like they could tell me big O notation. They could tell me like the best searching and sorting algorithms. They could do all kinds of cool academic stuff, but they just didn't feel comfortable with the programming. And so they came to the boot camp. And, it's always a joke that we developers tell each other, where the job interview is like, oh, implement Dijkstra's algorithm. And then the job is like, move these JIRA tickets across the board, right? Make that button bigger, or like make this compile. I don't know. So we take that joke and we make it like our reality and say, okay, what I need to do is train people how to get the job done. We want them to be effective developers. Now, it's important to know some amount of computer science, of course, but we don't have enough time to spend a lot of time teaching them math induction to prove that a loop finishes, right? We're just like, here is a list, here is a queue, here's a stack. Use these tools, right? It's a very vocational kind of thing. So we narrow down the field into the practical elements and get people out there ready to work and get their tech careers started. One of the examples that John likes to talk about is if you're learning to be a plumber, you don't need to know about fluid dynamics or metallurgy, material science, engineering, stuff like that. You just need to get the job done. And an analogy I like to use is a hospital, right? Like if everybody in the hospital is a brain surgeon, nobody's going to be changing the bedpans. So what we try to do is teach people what they need to know to get them started and see where their career can take them after that. So, you know, we teach programmers. But in order to teach programming, there's going to be a trick to that, especially for people who have never touched a computer before. We think of it as juggling 3 different things at the same time. There's always the syntax, right? If you have a concept in your head, but you're not exactly sure how to get it out into Java or into C# or JavaScript or Python or whatever your favorite language is, there's the whole ability of expressing yourself in the correct language. But then there's also the tool set, right? There's also the IDE. Are you using Visual Studio? Are you using IntelliJ? Are you using Eclipse? Are you using VS Code, which is becoming more and more more and more of a fan of VS Code, and so on and so forth. And then there's also the problem-solving aspect where you're like, okay, how do I do this? What are the patterns here? What can the computer do for me that I couldn't do myself mentally? Things like that. And so we try to keep all of these balls in the air that we're juggling and say, okay, remember, your problem here isn't that you took the wrong approach. The problem here is that you're, I don't know, returning inside of a for loop. So you're not actually going to get all the way through the loop. You're not going to really check all of the elements. Move that return statement outside of that code block. Oh, okay. There's also tools. That's an issue, right? We use Eclipse in the Java course, which has been giving us some issues, but that's okay. We love Eclipse. But getting students used to getting Maven dependencies to download in the background or stuff like that. I try to give them some other ways of looking at things so that they know that these issues exist across different platforms. For example, I'll do a command line compile of a Java program, just a hello world class, and say, okay, let's do it in the terminal window. Okay, great. Now let's do it in Eclipse. Just to say, here's what the IDE really does for you. It's pre-compiling things, showing you errors before you hit run, and so on and so forth. So there's a more deep understanding of how each of these things can work together. So if you are training somebody who is new to this, it's important to know that any of these things can go wrong. Like maybe they've got the syntax down, maybe they're great at Eclipse, but they're just taking the wrong approach to solving a problem, or anything in between. You can have any permutation of things going wrong here. Another thing to think about is it's not so much to just teach somebody how to program, right? And this is something else that we tell our incoming students is that you can learn to program for free. There are plenty of amazing tutorials online. There are plenty of videos, plenty of good materials out there. But what we try to do is to get you to get a job. We coach you. We teach you to work with other people. We do a lot of pair programming. We do a lot of group projects. We try to say, here's what you do in a technical interview. Here's how you present yourself. Here's what your resume should look like, and so on and so forth. And why? Well, it's because we don't really know how to hire programmers. And I know that's another thing that might rub some people the wrong way. But if you think about it, no two companies agree on how to hire a developer, right? Every interview process is completely different. Do we do brain teasers? Do we not do brain teasers? Do we do a whiteboard problem, or is it something that they've already seen before? Maybe we just talk to them about project work that they've done, or maybe they're faking it when they're talking about it. They're just describing what the guy who did all the work did. I don't know, right? It's very difficult to figure out if somebody would be a good match and an effective programmer for that particular job. So what we do is not only show them how to program, but also how to talk about programming. Because when you're in a job interview, you have to be able to articulate what is going through your head and be able to tell the person across the table, here's what I'm thinking, here's what I've experienced, here's a way for me to communicate to you that I know what I'm doing without just, coding your way into a job. And that's something that we drive home as well, is that you might be the best programmer who ever lived, but if you're a jerk, nobody wants to work with you, right? You have to be able to be a good teammate. You have to be able to communicate and collaborate. So we give them those tools. We have a whole other section of Tech Elevator called the Pathway Program, where we have people who are trained in helping you get your resume together, get your LinkedIn page looking good, and yes, do an elevator pitch, right? It's very difficult to sell yourself, especially if you're in this field because you love the meritocracy of it. Like, good code works, bad code doesn't. So if I write good code, I should get a good job, right? There's always an element of having to sell yourself, and that's always, always, always uncomfortable. But if you don't sell yourself, nobody else will. So we make our students do the elevator pitch, do all the uncomfortable things to help them get out there and get a job. But at the end of the day, people who make mistakes, people who take the wrong approach, people who screw things up, that's fine, right? People are going to make a mistake. Remember back to whenever you first learned how to program, it's going to take a while, and that's totally, totally fine, right? Don't make fun of the students. Don't give them a hard time. Make fun of yourself, right? Being self-deprecating is awesome, because it not only does it give you the same effect of taking yourself off of the pedestal that they implicitly put you on just for being their mentor, but it also lets you say, it's okay. It's totally fine. I was there. I was the new person once. You'll get there too. But it's important to say, even after all of that, even if you forgive all the mistakes, all the problems and all that, it's important to say, have respect, right? Know that this person is new. Know that they're trying. Know that they want this, right? And you want to help them get it. You can't push your motivation onto them. They can't borrow your will. They can't borrow your desire, but you can help them get to where they want to be, right? Help them help themselves. And show them that you are invested in their success. Show them that you really want them to do this, but they still have to program. The problem isn't them. The problem is getting the knowledge into them, right? So be respectful. Make sure that you show them that you're supportive and that you're proud of them, right? And that may seem a little, fatherly or motherly or whatever, but there is that a little bit of a relationship where you're passing along your knowledge and you're saying, I'm so glad you learned this. This looks great, and you're doing a great job. So it may seem maybe even a little condescending when it's two adults, but it's very important because it helps people who need that extra drive, that extra feedback to say, keep going, keep going, keep going. It's hard, it's difficult. There's always things that you'll need to learn. There's always some new framework. There's always some algorithm that doesn't make sense. But as long as you keep trying and keep getting back on the horse, or whatever the analogy is, you'll eventually get there. So those are kind of the important things of going from a practitioner to an instructor. So in summary, it's not for everyone, right? You can program, but you have to love it in order to stick with it long enough to become effective. Programmers learn by doing. I believe that's very important because I remember when I was in college, I did a lot of studying. I did a lot of trying to understand things, but I didn't always write the best code because I wasn't practicing it as often as I should. Our projects were big 2-week due at the end of the month kind of projects. And I felt like I would have benefited from more consistent, smaller, repetitive things just to get me to the point where I was comfortable. Kind of like learning a language, a foreign language. Let's see here. It is creative and intuitive. You do have to adjust your mindset. You do have to be able to do some pattern matching to know this problem might have been solved before, or there are other things that you need to put together. But if you build with bigger building blocks, you can put the building blocks together into a way that might be new or might be a fun way for you to experiment and keep the joy of programming alive in your own work. And then positive and encouraging support. It might sound cheesy to you, but it's extremely important, and it needs to be genuine, right? So it's, people can detect that, and it has to come from within. So that's it for the talk that I wanted to give on the things that I've learned from being an instructor. If anyone has any questions, my contact, there's my picture of me cheesing that's on the Tech Elevator website before I got LASIK. But anyway, if you have any questions for me, that is my contact information. You can look me up on LinkedIn. I was the first Tom at Tech Elevator, so I got the prestigious tom@techelevator.com email. So there you go. Okay. When you're learning to program, how do you overcome imposter syndrome? That is a fantastic question. That is very, very, very tricky. I think that it's important to celebrate the small victories. And I think it's always important to look back. One of the things that I like to do is early on in the cohort, I have one-on-ones with every student just to sort of see where they are. Because not only does it help them feel like I'm paying attention to them, and I am, I'm not just making them feel that way, but also it lets me see where they're coming from. I can customize my approach and my message to them based on what their background is. And I'll write it down, I'll remember it and say, okay, this person might, like, I had one student who was, he was an opera singer, right? And I knew that he had a musical background. I knew that he probably thought in those kinds of terms, but he'd never done anything programming before. And so he had some issues, and I hope he's not watching this because he's going to know who he is at this point. He had some issues, with imposter syndrome. And I remember saying to him, look at how far you've come, right? Think back to when you didn't know what any of these terms were, and think about how far you've come now. You can keep going on that path, right? The next step might be a little daunting, but look at how high up you are now. And I think that sort of gives him the encouragement that he needs to continue to take the next challenge. And I also tell him I have imposter syndrome, right? I don't always know everything that I'm talking about. Like sometimes I have to re-look up how do static initialization blocks work or whatever, just to make sure I really know what the JVM is doing, because it doesn't always, come up in my real life. And I'm like, I've forgotten things that I need to relearn. That'll happen to you as well. So I think the positive encouragement and the take a moment to sniff the flowers kind of an idea and say, look at how far you've come might help you say, oh, I didn't think I'd ever be here, and I'm here now. So where will I be a year from now, 2 years from now, if I continue to have this kind of motivation to learn? I'm glad to hear that. Do you have any advice specific to mentoring, teaching junior developers when everyone is working remotely? Well, that is painfully relevant these days, unfortunately. Working remotely is tough, right? Because there are a lot of times, the thing that we miss the most, I believe, is the students interacting with each other, because they feel a lot more like there's safety in numbers, or they're not alone in this journey. And they might be missing out on that in-person experience. So we try to replicate that. We take advantage of Zoom breakout rooms. We try to get them back together in different ways to share that experience. But if you're mentoring in a one-on-one scenario, you don't get to rely on other newbies making them feel a little more comfortable. And so generally what I like to do with students who are struggling in a remote session here is to say, I'll work with them to get them unstuck. And then I will say, okay, now is it clear what you need to do, even if you don't know how to do it just yet? And then push them off a little bit to struggle on their own. And then check in with them maybe 2 or 3 hours later to see if they've made any progress. I like to give them enough space to not be spoon feeding them. I don't want them to get into the point where they're so dependent on me. They're like, here, this doesn't work. And then I fix it. And they're like, okay, here's the next thing that doesn't work, right? I want to try to have that push and pull relationship where I say, what do you think you have to do next? and then give them direction to say, yeah, that's right, you are correct. You need to figure out a way to transform this JSON object into an array, or I don't know. And then how do you think you do that? Why don't you go and try and let me know if you get stuck, or better yet, let me know if you figure it out. And more often than not, left to their own devices, they'll calm down. They'll try to remember what they learned. They'll Google a few things. That's another thing that is interesting. Some students with backgrounds in things like, oh, I don't know, literature or comedy or poetry, I don't know, things like that, where plagiarism is the worst sin you could commit. And then telling them, yeah, you can go to Stack Overflow and steal code snippets. That's just mind-blowing to them. And so, I always teach them that it's kind of like adoption, right? Where it's like, that might not be your code originally, but that's yours now, right? If you go and adopt a pet, that is your responsibility. It's part of your program. So now that dog, even though it's like a 6-year-old, I don't know where this analogy is going, but if you adopt a dog, that is your responsibility now. It's okay that you didn't raise it from a puppy, but it's yours now. So you have to understand what it does, and you have to be able to defend it if somebody does a code review. So anyway, back to teaching people remotely, I think it's important to say, here's where you should go, see how far you can get on your own, and I'll check in with you in a little bit, because I want them to learn to fly, but I also don't want them to, crash land. So I'll check in every once in a while and make sure they're okay. Now, timing doesn't always work. Sometimes I'm in a meeting or whatever, but I'll block off things in my calendar and say, at 3 o'clock, let me know how far you've gotten, and let me know what you've tried. Let me know if you've used the debugger, that kind of stuff. Good. I'm glad to hear that. Thank you for the feedback, and thanks again to John for encouraging me and helping me out with the material for this.